we're going to go ahead and run through the CFA 5.1 to 5.3 answers here. And again, you'll have a hard copy, so make sure you're listening to the instruction here and writing down the answers so you've got a place to look to remember how to do these things when you're studying for the test. All right, so at the first part here, we're going to plot and label these points A, B, and C up here and connect them to make a triangle. Remember, we always start at the origin here. So in our coordinates here, -2, 2. So we always go left or right first, and then we go up and down on the y because x comes before y, and this is the x-axis. So -2, up 2, and we want to label our points. There's point A. Next one, point B, is -6, 2. So I go over 6. Again, start at the origin, at the 0 here, right in the middle, and -6, up 2, because it's positive on the y, and label that B. And then point C is -6, -3. So again, start at the origin, -6, -3. I end up down here because I'm on the negative side. And again, I'm going to go ahead and connect these to make the triangle. Okay, you could use a ruler or a straight edge if you'd like. Okay, so we've got our points there, and we've got our triangle ABC. And our job right here is to write a number sentence to calculate the length of each line segment. And remember, this is an absolute value situation where we can compare to these 0 lines, either here or in this case on the x-axis, to see how long these things are. And we don't even have to really have the picture, and we'd be able to tell how long these line segments are. So AB, when I look at A and I look at B, okay, remember the first thing you're going to see, you're going to kind of see if they're on the same street. So do you see how on their y-axis they're both at 2? That means they're both up 2 because we know the y goes up and down. So they're on this street. And I can see that right on that same line, up 2. So then all I have to do is look at their x-axis, or their x coordinate there. And I can see that one is -6 and one is -2. And we learn if they're both negative, okay, if they're both negative, then they are on the same side, so that's going to tell us that we need to subtract because we don't have to cross the axis. They're both on the same side. Okay, so we've got the absolute value of -6. So if I take the absolute value of -6 minus the absolute value of the -2, because this one is -6. So what we're looking at for the absolute value here, we're looking at how long AB is here. And I can see it's 1, 2, 3, 4. Okay, but if I look at that absolute value, remember this is -6. And so I can see that, and I'm going to draw it up here. You see how that's 6 away from our 0 line. That's 6 away from this axis. Whereas point A, you can see, is at 2 here, at -2. So its 0 line, it's only 2 away from that 0 line. So remember, if they're in the same, we subtract them. So this distance is absolute value. I know we're at the -6 location, okay? But its absolute value becomes positive, so this just changes. It's 6 from there to there, minus 2 from here to here, where the absolute value of that -2 to the 0 line is 2. So we subtract, and 6 minus 2, and we know that equals 4. Okay, so remember, we can just look up here and see if they're on the same street in the y. Then if I see they're both negative, I know they're on the same side, so I'm just subtracting their absolute values, which would look like this. And again, a little more complex. I could just look at these two and know how long it is without actually drawing the picture. Okay, so for BC, let me do a little erasing here. Now we're comparing B and C. And this time, you see on their x-axis, they're both on -6, which means they're both over 6. So we're on this street right here, you can see. And this time, one is positive and one is negative. That means they're on opposite sides of this x-axis in this case, or the 0 line we like to call it. So in this one, you can see the distance from here to here is up 2 to get to B. So we're looking at the absolute value of 2, which is the distance from here to that 0 line. And here we're looking at the absolute value of -3, because that's the distance from here to here. And if I add these up, one's negative, one's positive, so they're on different sides. So I need to add their absolute values. So I could say the absolute value of 2 plus the absolute value of -3 will equal 5, okay? Because I know this is 2 and the absolute value of negative 3 turns positive. So it's just 2 plus 3. Distance is always positive. So I can see how long these line segments are. And guys, we're getting ready to find the area of this triangle. Okay, and you can see it briefly down here. You can't see the line. I'll scroll down in a second. But remember to find the area of a triangle. Area, we know, is half the base times the height. Or some of you like to do base times height and then divide it by 2. Well, guys, I already see the base and the height. Usually you try to find that straight right angle. And in this case, either one could be the base or the height. A lot of times we'll rotate that triangle when we need to and have it on the bottom. But we know this is 4, we just found that. And we know the height, how tall this is 5. So I should know I can take 4 times 5, which would get me the whole rectangle, remember. Okay, it's not there, but imaginary. Length times width, 4 by 5 is 20. There'd be 20 squares in there, and I can easily see them all. But I got to cut it in half because this triangle isn't really here. I drew that extra part in to make that rectangle. So really, there's only 10. So I'm going to scroll up here. I'm going to erase. Make sure you pause the video if you need to make sure you get all this written. And we'll go answer this area question with the formula. And we just talked about it, so we'll just finish it up here. So find the area of triangle ABC, which we had drawn up here. And we already talked about the area is 1/2 the base times the height, because it's half of that parallelogram, or in that case it was a rectangle. So if the base was 4 and the height was 5, again, you can write this a lot of different ways, but we have to use, when we combine them here, parentheses to take 1/2 times the 4 times the 5. Remember, because of the commutative property, I can do it in any order I want. So I'm just going to take 4 times 5 is 20. And then 1/2 times 20 is 10. Okay, or you could be thinking 20 divided by 2, because we know cut in half could be 2. So it can be divided by 2. So 10 square units would be the area of that. And you could go back in your picture up top. I've already erased it. You could estimate and see that there are 10 in there. But we just follow that formula because, remember, the area of a triangle, it's half of a parallelogram. So find the base times the height, which is relatively the same as length times width, and just cut it in half because the triangle is half of it. Don't forget, you have to have square units as your label. We already had that written in there for you. Remember, that can also be written as units. You can put a little 2 up there, and it's red square units. And a lot of times you'll do that as you get older. Okay? So again, make sure you got these written down. We'll flip over to the back here and look at the last part. The last one is to find the area of a parallelogram. Okay, and kind of tough to see. We'll get it where we can see it here. We got that light right in the way. All right, so we got the parallelogram here. We can see that the base is 7, and a lot of you have learned that the height has actually got to be off a right angle. So it's written in here. This 4, the slanted part, is not the height. Okay, and if you guys remember, we can chop this part off right here. And if I just moved it over here and got rid of this, remember when we learned this, it just makes a rectangle. Okay, so you see why that 4 is not valid. It's 7 by 3. Okay, so we think when it's a rectangle, it's length times width. Well, we don't call it that because with the parallelogram, it's base times height, we call it. So area equals base times height. Because it's just a little different, and there's not 90-degree angles all the time in there, so we call it base times height. But it just ends up length times width. So you can see it's 7 times 3. So I get 21 square centimeters in here. If there were squares in there, all drawn in, 7 rows of 3. Okay, so again, even if this isn't here, again, you use the formula that it's base times height. And sometimes this isn't here and you got to draw this in or whatever. They might tell you. Sometimes it's on the outside and they'll tell you it's 3 centimeters out there. But if we know the formula is just base times height because we can move it around and make it look like a rectangle, that'll help you remember that formula. So 21 square centimeters. Again, I could write centimeters squared like that. Square centimeters. Same thing there. Okay. All right, so make sure you've got these all written down.